Good everyone, welcome to your favorite learning channel. My name is Oluwatoyin. Today we are going to discuss about IUPAC nomenclature of alkyne and alkanol. IUPAC nomenclature of alkyne and alkanol. In my last video, we discussed about IUPAC nomenclature of alkanes and alkenes. So today we look at IUPAC nomenclature of alkyne and alkanol. IUPAC nomenclature of alkyne and alkanol. IUPAC nomenclature of alkyne and alkanol. Then what is IUPAC nomenclature? Although I've explained the meaning of IUPAC nomenclature in my last video. IUPAC nomenclature is a method of naming organic compound as recommended by the International Union of Pure and Applied Chemistry. Method of naming organic compound as recommended by the International Union of Pure and Applied Chemistry. Then I've explained rules that we need to follow in naming organic compound in my last video under IUPAC nomenclature. Then what is the first rule that we need to follow in naming organic compound? The first step is to select the longest continuous carbon chain. Then you name according to the number of carbon atom that it contains. Then but under alkyne and alkanol, the first thing we need to consider in naming a structure of alkyne or alkanol is the position of our functional group. We consider our functional group in naming. Now let's look at naming under alkyne. Naming under alkyne. Don't forget that the "ine" from this word alkyne means what? Triple bond. Is triple bond. So it shows that we recognize a structure of alkyne by what? By the presence of triple bond in its structure. It contains triple bond in its structure. Then the general formula for alkyne is CnH2n minus 2. That is the general formula for alkyne. That is general formula. So we derive the molecular formula for members of alkyne from this general formula. We derive molecular formula for members of alkyne from the general formula CnH2n minus 2. Then, like I said in my last video, that members of hydrocarbons are derived from the following prefix. The members of hydrocarbon are derived from the following prefix: met, et, prop, but, pent, et, oct, non, and dec. So we derive name for members of hydrocarbons, that is the aliphatic hydrocarbons. And what are aliphatic hydrocarbons? We have saturated and the unsaturated hydrocarbon. Under saturated we have alkane. Then under unsaturated we have alkenes and alkyne. So when we are talking about alkyne, so I've explained alkene in my last video. Now alkyne. Now to derive name for members of alkyne, all you need to do is to add your name ending. The name ending is what? Is "ine". The alkyne ends with what? YNE, which is known as what? Which is pronounced as "ine". So all you need to do now to derive name for the first 10 members is to add what? The name ending "ine" to what? To the following prefix. If I add the name ending "ine" to the first one, we call it methyne. But methyne does not exist under alkyne. Methyne does not exist under alkyne. Why? Because the triple bond, which is ine, must exist in between two carbon atoms. The triple bond, which is ine, must exist in between two carbon atoms. Then if I use the general formula to derive molecular formula for methyne, so there will be presence of just only one carbon atom So therefore, methyne does not exist under alkyne. So there is nothing like methyne. There is nothing like methyne. So the next one will now be ethyne. Add your ine to it. Ethyne. Then the third one will be propyne. The fourth one will be butyne, pentyne, hexyne, ethyne, octyne, nonyne, then decyne. So these are the first 10 members of alkyne. These are the first 10 members of alkyne. So we can derive their molecular formula from this general formula. We derive their molecular from this general formula. N is the number of mole, that is the whole number. So ethyne is the second member of alkyne. Ethyne is the second member. So which means that N from this general formula will be 2. So you replace these two, substitute these two into this general formula to get your molecular formula. So if you substitute these two into this general formula, that will be C times 2 will give me C2. 2 times 2, 4. 4 minus 2 will give me 4. 2 times 2, 4. 4 minus 2 will give me 2. So the molecular formula for ethyne is C2H2. The molecular formula for ethyne is C2H2. So let's derive molecular formula for propyne. Propyne, the number of mole, that is the whole number, will be what? Will be 3. So let's substitute this 3 into this general formula. C times 3 will give me C3. 2 times 3, that is 6. 6 minus 2 will give me 4. So the molecular formula will be C3H4. For that of butyne, substitute 4 into this general formula. C times 4, that is C4. 2 times 4, 8. 8 minus 2 will give me 6. Then you can also follow homologous series in deriving the molecular formula for other members. Then what does homologous series says? It says that each successive member differ in its molecular formula by CH2. Each successive member differ in its molecular formula by CH2. That is, by adding CH2 to the first member, you get the molecular formula for the second member. When you add CH2 to the second member, you get molecular formula for the third member. Now, if I want to derive the molecular formula for pentyne without using my general formula, just add CH2. That is, 1 carbon atom to this C4 will give me C5. Then 2 hydrogen atoms to this 6 will give me H8. So C5H8. Then if you use your general formula, you are still going to arrive at the same thing. My N will be 5. C times 5 will give me C5. 2 times 5, 10. 10 minus 2 will give me 8. So, and so on and so forth. So you can continue like that, derive molecular formula for other members of alkyne. Then, how can we draw the structural formula for the following members of alkyne? How can we draw their structural formula? Now, the structural formula for ethyne is, the molecular formula for ethyne is C2H2. How can we draw the structural formula? We have how many carbon atoms? 2. Then the carbon atoms must be joined together by what? By chemical bonds. Then the ine, which is the triple bond, must exist in between what? In between carbon atoms. So it shows that we have to put our triple bond in between these two carbon atoms. The triple bond, which is ine. Your ine is the triple bond. Then don't forget that I said that each carbon atom in organic chemistry must be surrounded with 4 chemical bonds. Each carbon atom must be surrounded with 4 chemical bonds. So let's count the number of bonds that surrounded each carbon atom. 1, 2, 3. This one is 4. 1, 2, 3, 4. So each carbon atom must be surrounded with 4 chemical bonds. Then from this molecular formula, we have 2 hydrogen atoms. 2 carbon now, then 2 hydrogen atoms. So you attach your hydrogen atoms to those what? So to those 2 feasible bonds. This is the structural formula for what? For ethyne. This is the structural formula for ethyne. This is ethyne. This is ethyne. So let's look at the structural formula for propyne. Propyne with what? With 3 carbon atoms. Then those three carbon atoms must be joined together with what? With chemical bond. Then the ion, which is triple bond, must exist in between carbon atoms. So you can place it anywhere if you like. Your triple bond can appear here, it can appear here. So let me put my triple bond here. Then complete your what? Your chemical bonds now. Each carbon atom must be surrounded with 4 chemical bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So fill with what? With hydrogen atom. 3, 4. Then how many hydrogen atoms are we having from the molecular formula? That is 4 hydrogen atoms. So this is the structural formula for what? For propane. Why C3H4 is the molecular formula. Let's take one more member of alkyne. So that is butane. Let's draw the structural formula for butane before I proceed. Butane with 4 carbon atoms. Butane with 4 carbon atoms. 1, 2, 3, 4. The ion, which is triple bond, must exist in between what? In between carbon atoms. That is your ion. Then surround each carbon atom with 4 chemical bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then with how many hydrogen atoms? 6. 1, 2, 3, 4, 5, 6. This is the molecular form, the structural formula for butane. Then another thing, under naming of alkyne, we must consider the position of our ion. We must consider the position of our triple bond. You must consider the position of your triple bond in naming. Then, if you look at this, our triple bond, that is the functional group, is on the second carbon atom. If I count from the right hand side, 1, 2, it's attached to the second carbon atom from the right hand side. Then if you count from the left hand side, 1, 2, it's still on the second carbon atom from the left hand side. So it shows that you can name from both sides. You can name from both ends. So, and don't forget that when you consider your functional group in naming, you number from the side, which will give you the lowest to your functional group. Then don't forget that this triple bond is our functional group from this structure. The functional group of what? Of alkyne is C, triple bond C, because the triple bond must exist in between what? In between carbon atoms, in between 2 carbon atoms. Now, this structure, you can also call it but. Then you want to name your ion, which is triple bond. If I number from this side, 1, 2, 3, 4. From this side, my ion, which is triple bond, is on the second carbon atom. So I can call it but2 what? But2 ion. Because ion, which is my triple bond, is on the second carbon atom. So you can call it butane, then you can call it but2 ion. But it is very important, very, very important to name the position of your what? Of your functional group. To name the position of your functional group. Now, let's move to naming of alkyne now. Naming of alkyne. So when we have an alkyne group or the structure of an alkyne with substituents, let's look at structure of an alkyne with substituents. Structure of an alkyne with substituents. One, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then let's have substituents. Then don't forget that your substituent can be an atom. Your substituent can be an atom. Then when we are talking about atom, they are mostly what? Atoms of halogens. We always have atoms of halogens in structure. Then what are the atoms of halogens? They are fluorine, chlorine, bromine, and iodine. Then the fluorine will sound fluoro. Then chlorine will sound chloro. Bromine will sound bromo. Iodine will sound iodo. So when you see chlorine, you call it fluoro. Then when you see bromine, you call it bromo. Chlorine, we call it chloro. Iodine, then you call it iodo. Then your substituent can be an atom. I said mostly atoms of halogen because these are the atoms of halogen. That is the group 7 element. Then it can be an alkyl group. An alkyl group are also what? They are also substituents under alkyne. They are also substituents under organic compound. Alkyl. Alkyl. So members of alkyl are methyl, ethyl, propyl, butyl, pentyl, then and so on and so pentyl, hexa. Just follow your prefix, then add il, YL to it. So to get other name for other members. Then what is the molecular formula for alkyl? The molecular formula for methyl. Then we derive their molecular formula from the general formula CnH2n plus 1. That is their general formula. You can either derive their general formula from this general formula, or you derive their formula from molecular formula of alkane, because alkyl are derived as a loss of one hydrogen atom from alkane. If you go back to alkane, the first member of alkane is methane. So if the first member of alkane is methane and the molecular formula for methane is CH4, so the molecular formula for methyl will be CH3. So loss of one hydrogen atom from molecular formula of alkane will give you that of what? Of alkyl. I explained that in my last video. Now the molecular formula for methyl now is CH3. That is, you can derive it from this general formula. Methyl will be the first member, number 1. My N will be 1. C times 1 will give me C. 2 times 1 is 2 plus 1, 3. So CH3. So ethyl will be C2H5. My N will be 2. C times 2 will give me C2. 2 times 2, 4 plus 1, 5. So like that. This one will be C3H7. This one will be C4H9. Increase by CH2. They increase by CH2. So we are going to need this in naming of what? Of alkyne. And we are going to need what? The members of halogens. We are going to need members of halogens. Now, let's attach one of the these are substituents. Don't forget that I explained in my last video that alkyl are always substituents in organic chemistry. So let's add one of the substituents, CH3. What is CH3 now? CH3 is methyl. CH3 is methyl. Then let's add one substituent first and name. CH3 is methyl. Now we have one substituent. Then don't forget that whatsoever attached to our longest continuous carbon chain is our substituent. Whatsoever attached to your longest continuous carbon chain is your substituent. This is my longest continuous carbon chain. So therefore CH3 is my substituent because CH3 attached to the longest continuous carbon chain. Now, the first thing we need to consider in naming alkyne is the position of your functional group. You consider the position of your functional group. And what is my functional group from this structure? That's triple bond. I recognize this structure as an alkyne due to the presence of this triple bond. So this structure is an alkyne due to the presence of what? This triple bond in this structure. So now I will consider this triple bond in naming. So I will name from the end, which will give me the lowest number to this what? To this triple bond. I will name from the end. Since you can name from both ends, you can name from the right hand side, you can name from the left hand side. So you name from the end, which will give you the lowest to the what? to your functional group, which will give you the lowest to your functional group. That is the first thing to consider in naming alkyne. Now, from this right hand side, if I name from the right hand side, 1, 2. So my triple bond is on the second carbon atom. It's attached to the second carbon atom. But if I name from the left hand side, 1, 2, 3. So my triple bond attached to the what? To the third carbon atom. Then, and the rule says name from the end, which will give you the lowest to your functional group. So you name from the right hand. So the best position to name is our right hand side, because our right hand side will give us the lowest to our what? To our functional group. So it is very close to the terminal carbon atom. So you name from the end, which will give you the lowest to the terminal carbon atom when you consider your functional group. So 1, 2, 3, 4, 5. So after numbering, the next step to take is to what? To name your substituents first. You name your substituent before your root hydrocarbon. Your root hydrocarbon is this continuous what? Carbon chain. Your continuous carbon chain is your root hydrocarbon. So you name your substituent, that is the attachment, before your root hydrocarbon. Then, if you look at my substituent, which is methyl, CH3 is methyl. Methyl is on the fourth carbon atom, number 4 carbon atom. So what will I call it? 4-methyl. 4-methyl. Why? Because my methyl attached to the fourth carbon atom, 4-methyl. Then we don't have substituent again. Hydrogen atoms are not substituents. Hydrogen atoms are not substituents in organic chemistry. So we've named only the substituents that we have. So the next thing now is to name our root hydrocarbon, which is your longest continuous carbon chain. So 1, 2, 3, 4, 5. So the fifth member, number 5. So the fifth member of what? Of alkyne. That is, an alkyne with 5 carbon atom is what? Is pentyne. Pentyne. An alkyne with 5 carbon atom is what? Is pentyne. So which means that my root hydrocarbon is what? Pentyne. But you are not going to call it pentyne. Don't forget that I explained. Like I said, as our functional group must be named. The position of your functional group must be named. So you name the position of this functional group. So you call it pent. Then the ine is on what? On the second carbon atom. So you call it pen-2-ine. Don't forget that your triple bond is your ine. So your ine is on the second carbon atom. That's why you call it pen-2-ine. So the name of this structure is 4-methyl pen-2-ine. 4-methyl pen-2-ine. So let's take another structure with more than one substituent. Let's take another structure with more than one substituent. Then this is another structure. This is another structure. Now this time around, we are having two different substituents, C2H5 and C3H7. C2H5 is called ethyl, while C3H7 is called propyl. So when you have two different substituents, they must be named alphabetically. If there are more than one substituent, they must be named alphabetically. Now, this one, C2H5 is ethyl, while C3H7 is propyl. Alphabetically, E will come before what? P. So E comes before P. So it shows that we are going to name our E first, before what? Propyl. Ethyl before propyl. Then before naming, you have to what? You number your longest continuous carbon chain. Then you consider the position of your what? Your functional group before you number. So you number from the end, which will give you the lowest to the terminal carbon atom. So your terminal carbon atom can be your carbon atom at the right, it can be your carbon atom at the left. So now if you name from the right hand side, 1, 2, 3. My triple bond is on the third carbon atom. Is on the third carbon atom from the left. From the right to 1, 2, 3. My triple bond is still on the third carbon atom. So which one will be the best? Which side will be the best? Now, from this side, I want to consider my ethyl in naming. That is, ethyl will come first. Then ethyl now will be on the second carbon atom. But if I name from this side 1, 2, 3, 4, 5, ethyl will be on the fifth carbon atom. And alphabetically, ethyl will come before propyl. So therefore, the best position to name is what? Is from the what? Right hand side. Is from the right hand side. 3, 4, 5, 6. So we name alphabetically now. Ethyl will come before what? Propyl. Then my ethyl is on the second carbon atom. So we call it 2-ethyl, comma. Since they are not the same, we cannot bring them together. 2-ethyl. Then propyl is on the fifth carbon atom, number 5 carbon atom. So we call it 5-propyl. 5-propyl. Then you name your root hydrocarbon. Alkyne with 6 carbon atoms. Alkyne with 6 carbon atom is what? Is hexyne. Alkyne with 6 carbon atom is hexyne. Alkyne with 6 carbon atom is hexyne. So what you call it? Because you have to name the position of your yne. You have to name the position of this yne. So the yne is what? Is on the third carbon atom. Your yne is on the third carbon atom. So therefore, you call it X3 yne, because your yne, which is the triple bond, is on the third carbon atom. So the name of this structure is 2-ethyl 5-propyl X3 yne. 2-ethyl 5-propyl X3 yne. So let's have another structure with the same substituent this time around. Another structure with the same substituent. So let's have another structure with the same substituent. CH3, CH3. So hydrogen here. Now, let's look at this structure. We have two substituents, CH3 and CH3. That's methyl. Then the second one too is what? Is methyl. So we have methyl. Then what's the first step to take? What's the first step to take before we name? We number our longest continuous carbon chain. Then we have to consider the position of our functional group. So we name from the end where we have the least or the lowest to the terminal carbon atom. So if I number from the left hand side, 1, 2, 3, 4, my triple bond will be on the fourth carbon atom. Then if you number from the right hand side, 1, 2, my triple bond is what? Is on the second carbon atom. So you number from the side which will give you the lowest to the terminal carbon atom. So the right hand side will be the best side to what? To number. So we number from the right hand side. Now from the right hand side now, our triple bond, which is our functional group, is on the second carbon atom. So after that, you name our what? Our substituent. So we name our substituent first before our root hydrocarbon. So let's name our substituent. let's name our substituent. Then we have two substituents this time around, and they are the same, so we bring them together. So the first one is on the fourth carbon atom, number 4 carbon atom. So we call it 4, comma. Then the second one, this 4 is for the first one, the one up. Then for the one down too is on the 4th carbon atom, number 4 carbon atom. So another 4 for the second one. Then how many methyl do we have? 2. Then 2 in chemistry means di. We name 2 di. So that's di what? Methyl. Dimethyl. Then we name our root hydrocarbon. Then an alkyne with 6 carbon atoms is what? Is hexyne. So we call it X what? The ine, we have to name the position of our ine. The ine, which is our triple bond, is on the 2nd carbon atom. So we call it X2 ine. X2 ine. So this structure is 4,4 dimethyl X2 ine. 4,4 dimethyl X2 ine. Now I'm going to take a structure with 2 different substituents with a mixture of organic and inorganic substituents. With a mixture of organic and inorganic substituents. When we have a mixture of organic and inorganic substituents in our structure, when we have a mixture of organic and inorganic substituents in our structure, we name our inorganic substituents before the organic substituent. We name inorganic before organic. Members of halogens are inorganic because they are not organic what? They are not organic molecules. They are inorganic. While our key member are organic. So when you have a mixture of halogens and alkyne, you name halogen first. You name members of halogen first before members of what? Of alkyl group. Now let's have this structure with a mixture of organic and inorganic. Now, from this structure, we have bromine as substituent. Then we have what? Methyl as substituent. Methyl. Then bromine. Don't forget that bromine we sound what? Bromo. We call bromine bromo from this structure. Then, before we number, we consider the position of our what? Our functional group. Our triple bond is our functional group. We name from the end, which will give us the lowest to the terminal carbon atom. If I name from this side 1, so my triple bond is on the 1st carbon atom, but from this side 1, 2, 3, 4, my triple bond will be on the 4th carbon atom. And the rule says that name from the end, which will give you the lowest to the terminal carbon atom. So which means that the best position to name this structure is from the what? From the right hand side. 1, 2, 3, 4, 5. Then after that, you name your substituent first. We name our substituent before the root hydrocarbon. Your root hydrocarbon is this longest continuous carbon chain. Now, we have a mixture of inorganic, which is bromine, and organic, which is methyl. So the rule says that we name our inorganic before organic. It shows that bromine will come before what? Before methyl. Then the bromine is on the 3rd carbon atom. So we call it 3-bromo, comma. Then methyl is on the 4th carbon atom. That's 4-methyl. Then after that, we name our root hydrocarbon. Our root hydrocarbon will be the 5th member of what? Of alkyne. The 5th member of alkyne. An alkyne with 5 carbon atoms is what? Is pentyne. So it should be pentyne. Because we have to name the position of this ine, which is your triple bond. Then your triple bond is on the 1st carbon atom from this side. So it will be pent1 ine. So this structure is what? Is 3-bromo, 4-methyl, pent1 ine. 3-bromo, 4-methyl, pent 1 ion. So let's quickly talk about another organic compound, the IUPAC nomenclature of alkanol. Let's move to the IUPAC nomenclature of alkanol. IUPAC nomenclature of alkanol. IUPAC nomenclature of alkanol. Alkanol. Then alkanol has a general formula of CN H2N plus 1 then OH. So the functional group of alkanol is OH. So which means that we recognize members of alkanol by the presence of what? OH in its structure. We recognize a member of alkanol due to the presence of what? OH in its structure. So when you have a structure that contains OH, it shows that that structure belongs to what? It belongs to an alkanol. It belongs to an alkanol. And this is the general formula for alkanol. Now, from alkanol upward, the prefix we start with prefix. Their prefix starts with not like that of alkane, and alkyne. Their prefix starts with methan, ethan, propan, butan, pentan, hexan, heptan, and so on and so forth. So under alkane, and alkyne, we have met, et, prop, but, pent, et. But under alkanol, alkanoic, alkanoate, alkana, and alkanone, their prefix starts with metan, ethan, and at the back. So then after that, you add their name ending. So members of alkanol now. The name ending for alkanol is ol, OH. Then the ol means what? OH. So the name ending is ol. So to get name for the members of alkanol, you add ol, which is ol, to the following prefix. Ol. This one will be methanol, ol. This one will be ethanol, ol. This one will be propanol, butanol, pentanol, hexanol, ethanol, octanol, nonanol, decanol, and so on and so forth. Then you derive their molecular formula. From this general formula. What would be the molecular formula for alkanol? Alkanol is the first member. So my N from this general formula will be 1. C times 1 will give me C. 2 times 1 is 2 plus 1, that's H3. Then you add OH. This is the molecular formula for alkanol. Then for ethanol is the second member. So from this general formula, my N will be 2. C times 2 will give me C2. 2 times 2, 4 plus 1, 5. H5. Then you add OH. This is the molecular formula for alkanol. For propanol, my N will be 3. So C times 3 will give me C3. 2 times 3 will give me 6 plus 1. That is 7. So then you add OH. So like that. Now, these are the molecular formula for the first 3 members. Now, let's see how we are going to draw their structural formula. let's see how we are going to draw their structural formula. Now, the first member, which is methanol, this is the molecular formula. Then the carbon atom, see, we're having just only one carbon atom. Then don't forget that in organic chemistry, each carbon atom must be surrounded with 4 chemical bonds. So let's surround this first carbon atom. Since we are having just only one carbon atom from this structure with 4 chemical bonds. 1, 2, 3, 4. Then we have 3 hydrogens. 1, 2, 3. Then followed by OH. So you put your OH here. This is the structural formula for methanol. This is the structural formula for methanol. So let's look at this methanol. Methanol. Then for ethanol, C2H5. How many carbon atoms? 2 carbon atoms. So let's join those 2 carbon atoms together with chemical bond. Then each carbon atom must be surrounded with 4 chemical bonds. 1, 2, 3, 4. 1, 2, 3, 4. Then how many hydrogen atoms? 5. Let's bring in those 5 hydrogen. 1, 2, 3, 4, 5. Then followed by what? OH. So we recognize this a structure of an alkanol by what? By OH. That is, the OH is the hydroxy group, but we call it all under alkanol. The OH is an hydroxy group, but we call it all under alkanol. So this is the structural formula for what? For ethanol. So you can try other members. So draw structural formula for other members of alkanol on your own. Now let's move to naming of alkanol. Under naming of alkanol, after selecting the longest continuous carbon chain, the first thing you need to consider is your functional group again. You consider the position of your functional group in naming. Consider the position. So you name from the end, which will give you the lowest to the terminal carbon atom. That is, decide where your functional group is very close to the terminal carbon atom. Then, like I said, that your terminal carbon atom can be the carbon atom, the first carbon atom at the right hand side, or the first carbon atom at the left hand side. So you consider the position of your functional group. Then you name from the end, which will give you the lowest to the terminal carbon atom. So let's look at this structure. Let's look at this structure. So we recognize this structure, that this structure is an alkanol due to the presence of this hydroxy group in our structure. So OH is an hydroxy group. If there is no hydroxy group there, if I replace this one with hydrogen, it shows that this structure will belong to what? An alkane. But the presence of this hydroxy group now shows that it is an alkanol. It is no more what? An alkane. It is no more an alkane. So this hydroxy group, and we consider this hydroxy group in numbering before we number. If I number from the right hand side, 1, 2, OH will be on the second carbon atom. If I count from the left hand side, 1, 2, 3, my OH, that is my functional group, will be on the third carbon atom. So the best position to name is from the right hand side. 1, 2, 3, 4. Now, an alkanol with 4 carbon atoms. An alkanol, so because we are having 4 carbon atoms, the root hydrocarbon is 4. 1, 2, 3, 4. An alkanol with 4 carbon atoms is what? Is butanol, the fourth member. An alkanol, that's C4H9OH. So an alkanol with 4 carbon atoms is what? Is butanol. Since there is no substituent, OH is not a substituent this time around. OH is the functional group of what? Of this hydrocarbon. of this organic compound, because this is not an hydrocarbon anymore. So OH is the functional group of this non-hydrocarbon. Is a non-hydrocarbon due to the presence of this OH. If it's an hydrocarbon, it will contain this. Our structure will contain only carbon and hydrogen. It will contain only carbon and hydrogen. But this one we have carbon, hydrogen, and oxygen. So it is not a hydrocarbon. It is what? It is a non-hydrocarbon. So the non-hydrocarbon are the alkanol, alkanoic, and alkanoate. But this is an alkanol due to the presence of this OH in our structure. Now, so we have to name the position of this OH. Normally, our structure is what? Is butanol, the fourth member. We're supposed to call it butanol. But the OH is all. The OH is all. This OH is all. So we name the position of this all. The all is on the second carbon atom. The all attached to the second carbon. So I'll call it butan 2 all. Butan 2 all. So the name of this structure is butan 2 all. Butan 2 all. Then it is possible for you to have more than one all in your structure. If you have more than one all in your structure, let's add another OH to this structure. OH. So what are we going to call it? There's another all here. There is another all. So what are we going to call it? We name the position of the two all. We have to name the position of the two all. The first all is on the second carbon atom. We call it 2, comma. Then the second all, the second OH is on the third carbon atom, 3. How many all? That's 2. Then 2 in chemistry is di. You now call it diol. Diol. Di means what? 2 all. So it's butan 2,3 diol. Butan 2,3 diol. That's another structure. Then let's look at another structure. This is another structure. So this time around, we have 3 all. We have 3 all. There is one all here, another all here, another all here. Now, an alkanol with 3 carbon atoms, 1, 2, 3. With 3 carbon atoms, 1, 2, 3. An alkanol with 3 carbon atoms is what? Propanol. So we call it propan. Propan. So we have to remove all now. We remove all. Propan what? The first all is on the first carbon atom, propan 1, comma. Then the second all is on the second carbon atom, propan 1, 2. Then another all on the third carbon atom, 3. How many all? 1, 2, 3. 3 in chemistry means what? Tri. So we call it triol. Triol. Propan 1, 3, 2, 3 triol. You can also call it propane 1, 2, 3 triol. You can call it propane 1, 2, 3 triol. Then you can call it 1, 2, 3 propanol. You can call it 1, 2, 3 propanol. So let's check a structure with substituent. Like I said, that alkanol is not a substituent. The hall is not a substituent. So let's check a structure with substituent. Let's check a structure with substituent. So what are we going to call this structure? What are we going to call this structure? So we name from where we have the list to our functional group. This time around, our OH, which is functional group, is on the first carbon atom. So we name from this side since it is on the first carbon atom. 1, 2, 3, 4. Then we have substituents this time around. CH3, which is methyl. CH3 is your methyl. So your methyl is on the second carbon atom. Your methyl attached to the second carbon atom. So what will you call it? 2-methyl. 2-methyl. Then this is your root hydrocarbon. 1, 2, 3, 4. An alkanol with 4 carbon atoms is what? Butanol. But we call it butan. Butan. You have to name the position of your ol, OH. You have to name the position of this OH. So your ol, which is OH, is on the first carbon atom. So we call it butan 1 ol. Butan 1 ol. So the name of this structure is butan 1 ol. Butan 1 ol. So let's take 2 more examples. Let's look at this structure. Now, from this structure now, we are having 2 different functional groups. No substituent at all. OH is not a substituent. It is a functional group. Then triple bond is also a functional group. So we're having 2 different functional groups. Then in hierarchy, in organic chemistry, in hierarchy, OH, that is alkanol, is more than alkyne. Don't forget that an alkyne is the one having what? Triple bond. In hierarchy, alkanol is more than what? An alkyne. So therefore, you consider OH in naming. So you consider OH because alkanol is more than what? Alkyne. Alkyne is having triple bond in its structure, but alkanol is having what? OH. So OH is more than alkyne. So you consider alkanol this time around in naming. So alkanol is on the first carbon atom. So name from number from alkanol. 1, 2, 3, 4. Then we have 2 different functional groups, no substituents, because these are our root hydrocarbon. So no substituent. Then we have ine, we have ol. So I'm supposed to call it now 1, 2, 3, 4. 1, 2, 3, 4. We have the 4th member of what? Of alkanol. We're supposed to call it butanol. Then the ol. And at the same time, we have ine in our structure. Don't forget that under alkyne, the 4th member starts with but. Abi, the prefix for the 4th member is but. Then you add ine. So this time around, we now remove but. So we write but, ine, and what? And ol. Because we are having 3 things now. So we remove e at the back of ine. We remove e at the back of ine. So we have but, we have ine. Ine is triple bond. Then we have ol from this structure. Now we have to name the position of ine and ol. We name the position of ine. We name the position of ol. Then our name will now be, the name of this structure will now be but. The ine is on what? Is on the 3rd carbon atom. 1, 2, 3. Your ine is your triple bond. It's on the 3rd carbon atom. So we call it but3ine. But3ine. Then the ol is what? Is on the 1st carbon atom. 1 ol. but3-1-ol, but3-1-ol, or you call it 1 but3-enol, 1 but3-enol, or you call it 1 but3-enol. That is, the ol is on the first carbon atom, the I is on the third carbon atom. So you see that you call it but3-enol or 1 but3-enol, but3-enol or 1 but3-enol. Let's take one more example before we call it a day. Let's take one more example before we call it a day. So this is another structure of alkanol. We recognize this structure as an alkanol due to the presence of this OH, which is called hydroxy group or hall from the structure. Then we have substituent from our structure. Our root hydrocarbon is this, the longest continuous carbon chain, 1, 2, 3, 4, 5. There's another chain here, 1, 2, 3. Then there's 2, 4, 5. But the longest, the easiest way, the easiest chain is this one, the longest one, the straight one. So we consider this one. Now, our functional group now, which is all, from this side 1, 2 is on the second carbon atom. From this side 1, 2, 3, 4 is on the fourth carbon atom. So we consider the right hand side. 1, 2, 3, 4, 5. Then we name our substituent before the root hydrocarbon. Let's name our substituent before the root hydrocarbon. So we have two different substituents. C2H5 is what? Is ethyl. We have ethyl. We have ethyl. Then we have chloro. We have chloro. We have ethyl. We have chloro. Now, chloro is inorganic. Ethyl is organic. Then don't forget that we must name our inorganic before organic. So the chloro is on the fourth carbon atom. So what we call it? 4-chloro, comma. Then the ethyl is on the third carbon atom. 3-ethyl, 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 3-ethyl. Then our root hydrocarbon 1, 2, 3, 4, 5 will be the fifth member of alkanol. Then the fifth member of alkanol is called pentanol. Pentanol. Then we have to name the position of our ol. So we call it pentan. Pentan. Then the ol, which is OH, is on the second carbon atom. So we call it pentan-2-ol. So the name of this structure is 4-chloro, 3-ethyl pentan-2-ol. 4-chloro, 3-ethyl pentan-2-ol. So we've come to the end of today's class. If you like this video, subscribe to Royal Learning Channel. Then share this video with your friends. Then comment